The scene shows an aerial shot as if taken from a plane or helicopter. The camera is animated to fly in a straight line for 300 frames. In the top view, create a box between the camera and its target. The box will be used as a placeholder for the clouds. Set the box dimensions to 20 by 20 by 5 kilometers. The scene is quite large, so the units have been set to kilometers. Move the box up so that the camera is flying through it. Ultimately, this box will be hidden, so do not worry about it blinding the camera view. Create a PF source icon of any size in the top view. Set the viewport percent display to 100%. Since you'll be using a small amount of particles, this shouldn't affect the performance too much. Press 6 on the keyboard to open the particle view window. Set the birth operator to start and stop emitting at 0. This ensures all particles are visible from beginning to end. At this time, particles are positioned on the icon. They need to be inside the box. Replace the position icon operator with the position object operator. In the position object operator's parameters, use the Add tool and pick the box as an emitter object. By default, the particles are scattered on the surface of the emitter object. It is important to change that to volume if you want to create a 3D cloud effect. It is worth noting that you can also scatter particles based on material density. This can be useful if you want more particle concentration in one area than another. As an example, create a standard material and apply it to the box. At this time, you can hide the emitter box. You don't need to see it anymore. Apply a noise map to the diffuse color. It is important to use a 3D procedural map such as noise to fill the volume. A 2D bitmap would not work. Set its type to turbulence. Adjust the threshold and the size of the noise map to get good contrast between black and white. The effect is not directly visible in the viewport. To refresh the view, disable then enable again the position object operator. The white areas of the noise map are used to define particle placement. To better see the effect in the viewport, temporarily set the display to dots and increase the number of particles to 2000. If you need to, change the display color as well. Experiment with different values for the noise map. Remember to turn the position operator off and on again to refresh the particle placement. By default, the particles are traveling in the direction of the p-flow icon, in this case down. They're also currently traveling at high speed. Reduce the speed to about 0.2, with also a slight variation of 0.1 or 0.2. Rotate the p-flow icon in the direction you want the clouds to travel, for example -y. Right-click and delete the rotation operator, as you don't need to rotate the cloud particles in this example. Decrease the particle number to about 300. You can always change that number later if you need to. At this time, the shape of each particle is a cube. In fact, it can be better viewed if you set the particle display to geometry. It is obvious at this time that the particles are huge. That can be easily fixed by changing the size value of the particle shape operator. Of course, in the real world, a particle is a very small entity by definition. To simulate clouds using microscopic particles, you would need millions of them, which is not a practical amount for rendering.